Knowledge paper, The Perpetual Abundance Principle. PQNK, the Pristine Organic Farming System. Executive Summary. This knowledge paper elucidates the core principle of perpetual abundance that underpins the PQNK system. Using region-specific data for the subcontinent, average wheat yield of 2 tons/acre, we demonstrate that even with moderate yields, the soil's mineral capital is vast and underutilized. Nutrient deficiency is a symptom of a broken biological cycle, not a lack of physical resources. By adopting the PQNK lens to manage the soil's microbial workforce, farmers can access this perpetual abundance, eliminating external inputs and restoring ecosystem health. The paradigm shift, from soil as a container to soil as a biological portal. Conventional agronomy views soil as an inert container for soluble nutrients. The PQNK system is founded on a modern, systems-based understanding. Soil is not a container, it is a biological portal connected to a deep geological bank of minerals. The health of this living portal determines the flow of nutrients from the Earth's immense reserves to the plant. The evidence of abundance, a multi-tiered geological bank. We must directly compare the soil's mineral capital to the actual uptake of crops in the subcontinent to answer the practical question of need per acre. The per acre reality in the subcontinent, an undeniable disparity. Let us take the example of phosphorus, P, based on a 2-ton, 2,000 kilograms, wheat yield per acre. Availability per acre, the top 6 inches of 1 acre of soil weighs approximately 1,000 tons, 1 million kilograms. With an average concentration of 800 parts per million, the total phosphorus capital is 1 million kilograms times 800, 1 million, equals 800 kilograms of total P per acre. Crop uptake per acre, 2-ton yield. Grain removal, 2 tons grain times 4.0 kilograms P2O5/ton equals 8 kilograms P2O5. Straw removal, 2 tons straw times 1.0 kilograms P2O5/ton equals 2 kilograms P2O5. Total removal as P2O5, 8 kilograms plus 2 kilograms equals 10 kilograms P2O5. Conversion to elemental phosphorus, P, 10 kilograms P2O5 times 0.44 equals 4.4 kilograms of elemental P removed per acre. The revealing ratio. Total P in soil bank 800 kilograms, P removed by crop, 4.4 kilograms. This simplifies to a ratio of 182 to 1. This reveals that the total phosphorus reserve in the topsoil is over 180 times greater than the amount removed by a single harvest. Element, total in topsoil/acre, kg. Crop uptake/acre, kg, ratio, bank withdrawal. Phosphorus, P, 800 kilograms, 4.4 kilograms, 182, 1. Potassium, K. 14,000 kilograms. 12 kilograms. 1,167, 1. Nitrogen, N. 2,000 kilograms. 40 kilograms. 50, 1. Note, uptake values are estimates for a 2-ton wheat yield. The total in topsoil is the total element, not the plant available fraction. This table reveals an undeniable truth. Even for average yields in the subcontinent, the topsoil bank holds minerals in quantities that are 50 to over 1,000 times greater than the annual withdrawal by the crop. This is merely the surface layer. The complete geological bank has 2 deeper tiers. Tier 2, the savings and bonds, subsoil and weathered bedrock, a larger, slower-moving reserve. Tier 3, the central gold reserve, unweathered crust, the planet's virtually limitless mineral capital. The deficiency we see is a failure to access this bank, not a lack of funds. The PQNK engine, the microbial assembly line. The key to accessing the multi-tiered bank is biological. PQNK fosters a sophisticated microbial assembly line, a diverse consortium of microorganisms that work in a coordinated, sequential process to manufacture plant-available nutrients. Station 1, Primary Mining. The rock breakers, lithotrophic bacteria and mycorrhizal fungi dissolve parent rock, liberating elements from the geological reserve. Station 2, Biorefining. The solubilizers, bacteria, e.g., Pseudomonas, convert insoluble compounds into soluble, plant-available forms. Station 3, Logistics and Distribution. The couriers, the mycorrhizal fungal network transports solubilized nutrients directly to plant roots. This assembly line operates on a just-in-time principle, activated by plant root exudates. The plant orders the nutrients it needs, and the microbial workforce delivers them from the bank. The disruption, why deficiencies occur. Nutrient deficiency is a management failure that has shut down the microbial assembly line. Chemical fertilizers halt the plant's production of root exudates, laying off the microbial workforce. Tillage destroys the fungal hyphae, the critical infrastructure of the distribution network. Pesticides and biocides poison the essential workers of the assembly line. We are not solving a deficiency, we are creating a biological collapse that makes the system dependent on constant external intervention. The PQNK solution, principles for practice. The PQNK system is a management framework to restore perpetual abundance. Feed the system, not the plant, maintain a thriving soil food web with complex organic matter. Never disturb the assembly line, eliminate tillage to protect the fungal network. Maintain continuous living roots, keep the command center active to manage the microbial workforce. Foster biodiversity, support a resilient and versatile assembly line. Conclusion: a return to perpetual abundance. The PQNK lens demonstrates that the resources for productive farming are not scarce. For a farmer achieving a 2-ton wheat yield, the soil holds 182 times more phosphorus than the crop removes. The limitation is not a lack of minerals, but a lack of the biological key. By adopting PQNK principles, we become stewards of this sophisticated system. We can thus produce nutrition-dense food, save water, eliminate agrochemicals, restore soil, and alleviate poverty, all by partnering with the Paedar Qudratti Nizam Kashatqari. Glossary. PQNK, Paedar Qudratti Nizam Kashatqari. The regenerative and sustainable pristine organic farming system. Geological bank, the conceptual model of the soil and subsoil as a multi-tiered repository of mineral nutrients. Microbial assembly line, the coordinated, sequential process by which diverse soil microbes weather, solubilize, and transport nutrients to plants. Root exudates, chemical compounds secreted by plant roots to communicate with and manage the soil microbiome. Supplemental knowledge paper, Quantifying the Abundance. Preamble. This supplemental document provides the empirical backbone to the philosophical and scientific arguments presented in the main PQNK knowledge paper, the Perpetual Abundance Principle. The following data and analysis translate the principle of abundance into tangible, quantifiable terms, using region-specific yields for the subcontinent. It serves to remove any abstraction, making the undeniable disparity between soil reserves and crop demand irrefutably clear. The core data, Annex A, crop uptake versus soil bank reserves. The following table is the cornerstone of this supplement. It details the nutrient removal of major crops at typical subcontinental yields against the immutable background of the soil bank's total reserves. Annex A, crop nutrient uptake versus soil bank reserves per acre. Crop average yield, kg/acre. Phosphorus, P, uptake, kg/acre. Potassium, K, uptake, kg/acre. Nitrogen, N, uptake, kg/acre. Soil bank reserve, kg/acre. P, 800. K, 14,000. N, 2,000. Wheat, 2,000, 4.4. 10.0 44.0. Rice, 2,000. 4.2, 12.0. 38.0. Corn, 4,000, 12.0. 20.0. 112.0. Potato, 12,000. 9.6. 66.0. 60.0. Cotton, 1,400. 4.9. 11.2. 35.0. Sugarcane, 48,000. 24.0. 144.0. 96.0. Source, crop uptake data calculated from standard agronomic removal values. Soil bank reserve based on median global soil composition data, Sparks, 2003, for the plow layer. Footnotes on soil bank reserves. Phosphorus, P, 800. The 800 kilograms represents the total elemental phosphorus in the topsoil. The ultimate geological bank is the parent rock and deep sediments, a reserve of thousands of tons per acre that is continuously weathered by the microbial assembly line, making the P cycle truly perpetual. Nitrogen, N, 2000. The 2000 kilograms represents the total nitrogen in soil organic matter. The ultimate, infinite bank is the Earth's atmosphere, which is 78% nitrogen gas, N2. This atmospheric reserve is continuously replenished into the soil by nitrogen-fixing microbes, diazotrophs. Potassium, K, 14,000. The immense reserve in the soil's mineral structure alone demonstrates overwhelming abundance, and it is also continuously weathered from an even larger geological reserve. Analysis, interpreting the undeniable disparity. The data in Annex A reveals a consistent and staggering reality across all crops. The ratio of the soil bank reserve to the annual nutrient uptake is overwhelmingly large. Element, total in topsoil/acre, kg, crop uptake/acre, kg, ratio, bank withdrawal. Phosphorus, P, 800 kilograms, 4.4 kilograms. 182, 1. Potassium, K, 14,000 kilograms, 12 kilograms, 1,167, 1. Nitrogen, N, 2,000 kilograms, 40 kilograms, 50, 1. This means, for every 1 kilogram of phosphorus the wheat crop removes, the soil bank holds 180 kilograms in reserve. For every 1 kilogram of potassium removed, the bank holds a staggering 1,400 kilograms. Even for nitrogen, which has a smaller total reserve and higher plant uptake, the bank holds 45 times the annual withdrawal. This pattern holds true even for the heaviest feeder, sugarcane. While it removes 24 kilograms of phosphorus, the 800 kilograms reserve is still 33 times larger than this substantial withdrawal. Implications for the PQNK system. This quantitative analysis leads to two inescapable conclusions. The problem is access, not scarcity. The data proves conclusively that mineral deficiency in agriculture is a management failure, not a resource shortage. The soil is not poor, our methods are. The crisis is one of liquidity, not capital. The folly of input-based agriculture, the practice of applying, for example, 50 kilograms of P2O5 fertilizer to meet a wheat crop's need for 4.4 kilograms of P is revealed as fundamentally illogical. It is an attempt to solve a biological access problem with a chemical brute force approach that further damages the very biological system required for the solution. Conclusion: data as a testament to natural design. This supplement provides the numerical proof that validates the PQNK paradigm. The perpetual abundance is not a philosophical concept but a quantifiable reality. The figures in Annexa should liberate the farmer from the fear of scarcity and redirect their focus from procuring external inputs to nurturing the internal, biological key, the microbial assembly line. The annotated reserves for P and N further strengthen this argument, revealing that the soil bank is not a static pile of minerals but a dynamic interface connected to infinite reserves, the bedrock and the atmosphere. By adopting the PQNK principles, we shift from being miners of a finite resource to wise managers of an infinite, self-replenishing system. The data shows us unequivocally that the path to sustainable, prosperous agriculture lies not in the fertilizer bag, but in the life within the soil. Any production process that inundates soil with water, disturbs soil through tillage, or leaves soil bare without organic mulch cover does not qualify as natural ecosystem science for production agriculture, PQNK, picnic.